Hello, my name is abdelrahman and today we're going to be talking about equilibrium of a rigid body. So what are the conditions for a rigid body equilibrium? The body in equilibrium if the resultant force and the resultant moment are both equal to zero. The equilibrium of a body is expressed as the examples we can see here. F r equals sigma f equals zero, and moment r or moment r of point O equals sigma mo, which equals to zero. As you can see in figure A, there is all of these forces and moments, and figure B just simplifies them into two. Support reaction. If a support prevents the translation of a body in a given direction, then a force is developed on the body in the opposite direction. If rotation is prevented, a moment is exerted on the body in the opposite direction, as you can see in the figures I have provided below. So we have 10 types of connections. So first one is a cable, and it has one unknown. The reaction is a tension force with which acts away from the member in the direction of the cable. 2 is a weightless link. One unknown. The reaction is a force which acts along the axis of the link. 3 is a roller, which has one unknown. The reaction is a force which acts perpendicular to the surface at the point of contact. 4 is a rocker. It has one unknown. The reaction is a force which acts perpendicular to the surface at the point of contact. 5. A smooth contacting surface. One unknown. The reaction is a force which acts perpendicular to the surface at the point of contact. 6. We have a roller or pin in a confined smooth slot. One unknown. The reaction is a force which acts perpendicular to the slot. 7. We have a member pin connected to collar on smooth rod. One unknown. The reaction is a force which acts perpendicular to the rod. The first 7 have one unknowns. Number 8 has it is a smooth pin or hinge. It has two unknowns. The reactions are two components of force, or the magnitude and direction theta of the resultant force. Note that theta are not necessarily equal, usually not, unless the rod shown is a link as in figure 2. 9. A member fixed connected to collar on smooth rod. Two unknowns. The reactions are the couple moment and the force which acts perpendicular to the rod. Fixed support, it has three unknowns. The reactions are the couple moment and the two force components, or the couple moment and the magnitude and direction of the resultant force. These are the 10 types of connections we can get and their number of unknowns. So what is the procedure for drawing a free body diagram, or FBD? Draw an outline shape. Imagine a body to be isolated or cut free from its constraints. Show all forces and couple moments. Identify all external forces and couple moments that act on the body. Identify each loading and give dimensions. Indicate dimensions for calculation of forces. Known forces and couple moments should be properly labeled with their magnitudes and directions. So what is the equation for equilibrium? Sigma fx and sigma fy represent sum of x and y components of all the forces, and that is for a rigid body in 2D. Sigma mo represents the sum of the couple moments and moments of the force component. So as you can see provided below is sigma fx must equal 0, sigma fy must equal 0, and sigma moment of point O also must equal to 0. So what is the procedure for analysis? Force or couple moment having an unknown magnitude but known line of action can be assumed. Indicate the dimensions of the body necessary for computing the moments of forces. So what is the procedure for analysis in more details? Apply sigma mo equals 0 about a point O. Unknown moments of are 0 about O, and the direct solution, the third unknown, can be obtained. Orient the x and y axis along the lines that will provide the simplest resolution of the forces into their x and y components. Negative result scalar is opposite to that was assumed on the FBD. As you can see, if you get a negative result, it is opposite of what we assumed on the free body diagram. So let's take here this example. So as you can see, we're trying to look for trying to find the equilibrium of forces, and that's a three-part question. So first we get the moment of point A. So MB multiplied by 6 meters plus 6 meters cosine 45 will then equal negative 10 kilonewtons multiplied by 2 plus 6 meters cosine 45, which then further simplification is negative 5 kilonewtons multiplied by 4, which equals 0. MB equals 8.047 kilonewtons or 8.05 kilonewtons. That is the moment of point A. Fx, sigma Fx must equal 0. So we're going to do 5 kilonewtons cosine 45 minus AX. AX is unknown, which equals 0. And the answer, final answer, is 3.54 kilonewtons. Finally, we get the sigma Fy, which is also must equal to 0. So AY plus 8.047 kilonewtons, which we got from the moment, minus 5 kilonewtons sine 45 degrees, which is already given, minus 10 kilonewtons equals 0. This is all the forces provided on the y-axis. So AI will then finally equal 5.49 kilonewtons. We just equate the problem to 0, and then we have to get the forces, either if we're looking for the sigma Fx, which is all the forces on the x-axis, or we're looking for the y-axis, the forces acting on the y-axis. Let's take this for example. For figure 2, determine the horizontal and vertical components of reaction at the pin A and their reaction on the beam at C. So first let's start with finding the moment at point A, which must equal 0 as I said before. FCD sine 45 multiplied by 1.5 minus 4 kilonewtons multiplied by 3 equals 0. So FCD equals 11.31 kilonewtons or 11.3 kilonewtons. Let's look for sigma Fx, which must equal to 0. So Ax, which is unknown, plus 11.31 kilonewtons cosine 45 equals to 0, which gets us the final answer of negative 8 kilonewtons. So on the free body diagram, we were wrong. It is 8 kilonewtons to the left. Finally, we have to get the sigma Fy, which must equal to 0. Ay plus 11.31 kilonewtons sine 45 minus 4 kilonewtons equals 0, which gets us the final answer of negative 4 kilonewtons, which makes our assumption in the free body diagram wrong. So it's 4 kilonewtons downward. Let's look at this example. In figure 4, the beam of negligible weight is supported by two springs. If the beam is horizontal and the springs are upstretched and the load is moved, determine the angle of tilt of the beam when the load is applied. As you can see, this problem might seem a little complicated, but it's actually not. First, let's start with getting the moment of point A. So FB multiplied by 6 minus half multiplied by 600 multiplied by 3 multiplied by 2 equals 0, which gets us the force of point B is 300 newtons. Let's get the moment of point B, which must equal 0. So half multiplied by 600 multiplied by 3 multiplied by 4 minus FA, which is unknown, multiplied by 6 equals 0, which gets us the final answer of 600 Newton. Thus, the stretches of springs A and B can be determined from 600 equal 1000 XA. XA is 0.6 meters, or the stretches of the spring representing X. And for FB, 300 equal 1500, basically the force, which then multiplied by XB, XB is equal to 0.2 meters. So the geometry shown in figure B, theta equals sine to the negative or the inverse of sine multiplied by 0.4 over 6, which equals 3.82 degrees, which is the answer we are requiring. So to make it simpler, there's a free body diagram I provided below at the end of the question that shows how we got these numbers and why these numbers were provided in the formulas. I hope this helped you understand the topic, and I hope to see you again. Thank you very much.